starts out kind of going like this way here. It doesn't see anything, so it starts, I guess, rotating a bit, and then suddenly it sees a target. And so that changes how it rotates, and then as it moves, it then suddenly doesn't see the target anymore because now it's out of view, and so it starts rotating again, and so you get this kind of spirally pattern to find one. It gets 1,000 steps to find the first target. As soon as it finds the first one, that target is removed, and then it has to start scanning again for the next one, and then when it reaches that one gets removed. Also, when it reaches a target, its step counter goes back to 0, so it gets another 1,000 steps to find the next one. And I'm not sure why it's not stopping when it gets down to less than 10, but basically it has found now a program that will get it to these 2 targets. And the fitness is 5, so it's trying to minimize that number. Oh, and it found one that gets both of them.
Why is it ending with the circle?
Because once the last target gets removed, it just sits there and starts scanning around for another one. And it doesn't see one. So it just spins around and around and around. That's a good question, though. Okay, so I could put another target on the screen. Let's see, here's one.
Still using all the same operators that we have?
Mm-hmm. Well, I have multiply, add, divide, tangent, log, and then the if positive, which was that one with the 3 children. I showed that to you last time.
Sort of. Conceptually.
So I put that in there because we want a robot to be able to make decisions. Let's see. What do you think about this? So what would the result of this be when x is 3?
It's greater than 0, so we 10. 10 plus 5 would be 15.
So if x is 3, then what's x times 2? 6. Is that greater than 0? Then the result of this if then is 10, right? And we add that to 5, for a total of 15. What if x is negative a half?
20.
25.
Well, 20 plus 5.
It would be 1, but yeah, 20.
Negative 1.
So this would be negative 1?
Yeah.
Is it greater than 0?
No.
So
20.
20 plus
5.
5. So this is you know, an if-then, but instead of it being kind of like a Java if-then, see, in Java we have if, condition, then you do statement, else, statement. This is different from this one in what way?
You have a statement before if.
one looked like this one,
Yeah.
I'd have to do 5 plus in here and 5 plus in here.
5 plus, yeah, first
So-
statement would be
so what-
5 plus 10.
There's a fundamental difference between the way Java does if else and the way something like Excel does if else. And that difference is in Java, if this condition is true, statement here means do something, else do something. But in Excel, when you have an if-else, if-then, this doesn't mean do something, this means the whole result of this expression is this value, which can then be added to another value, or multiplied, or embedded in another if-else. So in something like Excel, the if expression is the if thing is actually an expression that evaluates to a value. Whereas in Java, if is a statement. What's the difference between a statement and an expression? Expression will yield a result. Statement. What about statement?
Do something.
What's the result of a statement?
An action.
An action, true or false? If I say x equals 10, what's the result of this?
It's an expression. Wait, is that?
Sets
It's a statement.
x equal to 10.
Well, what's the result of
It's
it?
a command.
There is no result. It just does something, right? It assigns 10 to x, and then,
Stored it.
but that's it. You know, I can't say print, because this doesn't result in some value that can be displayed. I can display x, that's another statement, but I can't display the result of assigning 10 to x. Okay, so a statement in a programming language is just an instruction to say do something, but it itself has no value. An expression, like said, evaluates to a value. So in Excel, if is an expression because it results in one of these two values. And that expression can be plugged into another expression. In Java, if else is a statement. Do this or do this. Is it correct for me to write just one statement here?
Yeah.
I mean, is this the correct way to write out how if else works? That if this condition is true, do a single statement, else do a single statement?
It's not the only way.
Yes.
What's the other way?
Right.
Okay, Philip says yes, Ross says no, this is not the whole picture.
You can do else if.
She's saying just for that.
You do more than once. Or you can do zero.
Okay, so this part is optional here. So was it else if?
Yeah, but that's not what you have there.
We had a third
It's a whole
statement.
other-
Okay.
You say else if, or.
We're
forever.
digressing into language theory here, which I think is good. Okay, so Ross says another way to do this is if, condition, statement,
Yeah.
else, if, condition, statement, else, statement. Right?
And
That's
then
another way
I'll
to do it.
just say that's not the right way to do it. It should be if, else if, else if, else.
So there's another one, right? But this, what I've drawn right here, is the entirety of if and else. That over there is two statements. Where's the first one?
If,
Starts here. Where does it go?
And after the first else above if.
Right there. So what is the statement that the else does?
Calls the next if.
The if, right? So this is the second statement here. So this is actually two statements.
That was nested.
it's gotta be cursive, call it southwest?
Yeah, it just means that if this is true, it does this thing. If this is false, it does this thing. And then this one, if this is true, it does this thing. And if it's false, it does this thing. Okay? So actually, the chain of ifs and else ifs are just multiple statements. Okay? Someone else said, you actually go like this. If, condition, brace, statement, semicolon, statement, semicolon, right? And then else, brace, yeah, you got it, right? Guess what? Where's the statement start?
Yeah.
Here? Where's it end?
The else.
All the way at the bottom.
All the way to the bottom, okay? Are there any other statements here?
The else.
The else is?
Stuff inside the if articles.
Here? Is this a statement? Yeah?
Says statement.
Is this a statement?
Says statement.
Yeah? And then there'll be some here. You see any others?
The condition.
No, that's an expression. Here's one. And here's another one. So it turns out, in Java, when you have a brace, and then statement, this whole thing is the statement. It's called a compound statement, or it's just called a block. And you can put them anywhere you want inside a program. Take a look at this. Let's find something.
Killed it.
Yeah, well, we got pretty close. That's good stuff in there. Let's find a good place to do this here. This is the result of my 3 a.m. Oh, this is working. It's not quite working. It's working. It's not quite working. Oh, here's one. Okay, so I've got these 4 statements right here. See them? It turns the pen down, it sets the color to green, hides the turtle, sets the speed to 1. Actually, we never use that function, so we'll look at this one here. Set the pen down, hide the turtle, set the speed. Okay? Will that work?
According to your theory.
Compile's fine. So I just turned 3 statements into 1. What can I do with that?
Give it its own
You can
method.
give it its own, like, assigned name, and then you can call it what?
Well, that's called a method or function. But by putting braces around these 3 statements here, I've isolated them. Any variables that I declare within that block only exist within that block. So if I've got a whole chain of stuff to do, you know, like let's say I want to do the distance formula. Right, what's the distance formula? E is equal to square root
X initial minus X final.
x1 minus x0 squared plus
Anything with y.
y1 minus y0. Okay? And so let's say instead of writing out one big giant expression, I want to kind of isolate it, break it up into little pieces. So I could call this dx, delta x, and this one here is dy, so I might go double dx equals x1 minus x0, double dy equals y1 minus y0. Are we good? And then we could go double, what's this whole thing called? The expression. It's actually the hypotenuse of a triangle, really. Dx times dx plus dy times dy, right? And then finally, double distance equals math dot square root. Okay, and so we took this whole thing, we broke it down into individual pieces. So out of the 4 variables I created, which is the one that I'm concerned about? Which is the one I really want? This one here. All these others are throwaways. But by declaring them within my giant method, these variables now exist from this point forward. And I can't redeclare them. I can't use them for some, I mean, I can't like, what am I saying here? I can't redefine them elsewhere, down below. But what I could do is I could do something like this, and then I'll move double distance to the base. Yeah. So now I have distance, which exists outside the block. I've declared dx, dy, and hypotenuse within the block, assigned a distance inside the block, but then once I exit the block, which variable exists? Only distance does. The other gets thrown away.
Isn't that making a method?
But it's kind of like putting the body of a method within a method for the purpose of isolating these variables so that I don't see them outside of the block. So this whole thing is a statement. Inside of it are 1, 2, 3, 4 other statements. It's kind of a cool programming technique.
Would that be considered bad style though? I mean,
No.
no?
No.
So this is really just an attempt by the guys that wrote Java to help with house cleaning because the janitor's really bad.
Pulls out his tools, makes a mess, and then doesn't clean up.
Yeah.
So it's like assembly we can use R16 over and over again. Like
Kind
once you
of.
set, something to equal R16, then you can use R16 again.
But it's sort of an assembly. It's like you have 32 variables that are just always there. And you never have to declare them. They're just there. And you can reuse them willy-nilly because they're just there. In this case, I'm declaring a scope to say these 3 variables are only exist within this block. Once we leave this block, they're gone. And I can define new ones that are different from these ones over here. So it is kind of like a house cleaning thing, but it's not like the designers of Java said, hey, we want to make this happen. This just happens because the definition of a statement is it's an assignment, or it's an if, or it's a for loop, or it's a while loop, or it's it's a method call, or it's a block.
So are we assuming that it already has a value for x and y, or are we going to plug those in?
These here?
Yeah,
Yeah, they were defined up here.
they're defined up
Like
there.
maybe they were passed in.
Okay.
Yeah, they were calculated. So there is, for every programming language, there's this thing called the grammar, which says how programs are constructed. And there's the grammar says a statement is, this means is, if expression statement semicolon else statement, or, this means or, it's while expression statement, or for statement, semicolon, statement, semicolon, statement, statement, or variable equals expression, or curly brace statement, semicolon, and then this special symbol here that means any number of statements, regular expressions, right? Okay, so that's basically all of Java's grammar right there. Notice that it's recursive. A statement can be built up out of a curly brace and one or more statements. So how are these statements constructed?
Same way.
So exactly the same way, which means that I can put an if inside of curly braces. It means I can put two sets of curly braces around these.
So, is
What?
all the grammar defined?
What am I doing?
Compile.
Oh, well, it did.
With the blue jay like that?
All you gotta do is type it. It compiled it.
Oh, you're using, that's right, you're using.
Will BlueJ like it? BlueJ uses the same compiler Eclipse does. It's the same Java on both versions.
Is there a different Java?
No? Well, no, the grammar is the same for all of them.
I was just wondering.
No, it's
maybe
actually
we're
it's
holding
actually a
out.
common misconception that BlueJ's Java is different than Eclipse's Java. It's the same. It's the same Java. Is this interesting to you guys? If it's not, I can stop.
Yeah.
About this.
Yeah.
I mean, you're gonna have to learn this, probably in. You'll take a class at whatever four-year place you're going to called either programming languages or compiler construction. This will get drilled into you over and over and over again. Statement. Okay, can you see this? A statement is a variable declaration, or it's an expression followed by a semicolon, or it's a statement block, which is one of these things, or it's an if, or it's a do, or it's a while, or it's a for, or it's a try, or it's a switch, or it's a return followed by an expression, or it's a throw followed by expression, or a break followed by an identifier, or a continue. This is basically the guts of Java right here.
What is a synchronized?
Do is a loop. It's called the do-while loop. The while is just moved to the end, so it evaluates the expression, the condition after it does the loop instead of before.
So you say do.
And then a block.
Statement.
Your statement and then wow.
Yeah. So it's guaranteed to go through the loop at least once, whereas a while is not guaranteed to go through it once. Synchronized means if you have two if you have two threads in your program running and you want to make sure that the threads don't do exactly, that they reach the same point in their program at the same time, you can say synchronize here. So for example, if you've got two threads, each of them doing an expensive calculation, computationally expensive, one maybe takes 2 seconds to do it and one takes 1 second to do it, and you want both of them when they get done to wait until the other one finishes, then you say synchronized. A statement block is a brace followed by one or more statements followed by, a brace followed by a statement followed by a brace. Oh, we already said that a statement was, where is it? Somewhere in there.
Just a semicolon is a statement, so that'd be invalid.
You think so?
Double semicolons. That's, I don't like that.
Yep.
Good stuff.
It's the end of nothing.
The expression before it happens to be nothing, but
Really inspired us to make like really obnoxious code from now on. Like, please,
it would
yes,
be a
read
sad
this.
day.
Yeah, exactly.
nothing was not a valid expression.
Just, yeah, screw up your programmers and use them.
Things get crazy.
Perfectly valid Java.
That's just commented out, right?
Yeah.
Put anything there.
Oh yeah, do stuff like this, right?
Why? Because you can.
Because you can.
should.
You can do Java poetry now, right? now that you know that you can do these things.
Cummings.
Yeah. Oh, there's, do you think it doesn't exist?
Open, oh man. I love that.
Oh, put on the open mic.
I'm so excited.
Oh, well, that's probably like, actually have coffee.
The Java open mic, it's like real dribble.
What do you say? If else,
Angel
input,
fire poetry.
Put
X
Java
equals-
programming poetry.
X equals happy, Y equals sad.
I certainly know
There's that
If X-
XKCD
X
comic
is
where they
equal.
like.
Why?
If X
It is
bracket,
not happy.
smile.
Have you seen the XKCD comic with
Print
like
lines,
simulating
throw
playing
that out,
catch with
print
his dad?
Perl is much better at poetry.
Please script breastfeed my hat, my cat.
Yeah, but with the
Oh,
poetry,
that's
you have to write
beautiful.
everything, like your bracket.
I mean, not only does it have to be, you know, poetic, it actually has to be
Bilbo
a program
Baggins.
that actually does something. You know?
Use your feet, semicolon, use constant,
On and on.
bracket,
True.
on and on.
While the road equals on and on.
Equals or greater than one, comma, true, equals and greater than one, comma. I don't know, it's a poem.
So, getting back to our program. Oh, I need to fix this. Move that here. Do this extra stuff.
Well, if it's valid, why did you fix it?
Let's be poetic now, come on. Put a poem
So,
in.
getting back to our program. Let's set it running again. We worked on get last time. Yeah, I'm going crazy.
What would be an example of a quadruple operator?
Does it matter?
Make one up. Let's build
Well, if they're
if
there,
statements.
I mean, what would it be?
Well, maybe this is if it's less than 0, equal to 0, greater than 0. Okay, how do we number this?
With the 0 at the
Count all of
top?
them. Oh,
Okay.
0.
0?
Yeah. And then start going to the left.
So you
Yeah.
give yourself,
Go to
I
the,
remember what the rule was. I think Paul came up with this.
There's-
Assign yourself.
there's the
as
manager
star.
on the left. You go and ask the manager how many people work for him. He asks the people who work for him how many.
Tells you what your number is. Then number to the left. Then
Yeah, well, I only know how it works with CEOs and managers.
number.
Then you tell
Here it
what,
tells you what your number is, then you number
Number your-
yourself, and then
Yeah,
you
that's
pass
what
your
this
number
is.
plus 1 to the left.
So number your leftmost child, greater than you by 1.
Okay.
And then moving right, add the count from that child plus your number plus 1.
Number next. Child, your number plus count of what?
Of the left, or the previous child. Plus 1.
And this is actually, yeah. Because if we have 4 here, you gotta do all this. Okay, so your parent tells you what your number is, number the leftmost child using your number plus 1, and then moving right, number the next child with your number plus the sum of the counts of the previous children. And actually this rule here works just fine for the second one, it's just that the number of children is 0. So it becomes your number plus 1. So the parent, which is the one up here, says your number is 0. So it gives itself 0, and then what?
Yes, it's kid.
your number's 1.
Tells this one here, your number is 1.
Because your number's 2.
How many you got?
Well, then
It'll be
what does this child do?
Passes it to the left.
This one went, oh, my number's 1. In the little child voice, right? My number's 1. And what does it do?
Like Beyonce says.
So it goes, sends 2 down to the leftmost child. This child goes,
My number's 2.
my number's 2.
In an even higher pitch, more child voice.
They getting younger.
So this one over here, 3,
Don't mind that number.
no children. So it goes back up,
1.
and this one takes its number plus number of children over here,
And then goes to the right.
Plus 1.
plus 1, tells this one 4.
All right.
Number back up.
Okay, we're done.
With number 3.
That's it.
This one comes up here and says, my number plus number of children over here, which is 3, plus 1,
Plus 1.
3 plus 1. Yep.
5. Yep, does that work? This one sends a 6 down, and then over here we get 1 plus 2 plus 3 plus 1.
7.
7. And over here we get 1 plus 1 plus 2 plus 3 plus 1.
I'm guessing it's 8.
I'm going with 8.
Well, this is, let's see, 1 plus, this is 2, 3, 4, 5, 6, 7, plus 1 is 8. Yep. And then to the left, down, and then come all the way over here, and this is 11, 12, 13, 14, 15, 16. All right. And then we wrote, and I posted on this weekend how get works. Did you see that?
No.
Just posted it last night. Not this weekend.
So here's what you should be working on in your project, is you should be putting a get method in there. So functions need to know how to get. That means all the expressions need to know how to get. So you're gonna basically implement a get all the way through your whole project. All functions need to know how to count, and I think that's already in there. And then we need to do replace. If I go f dot replace, let's do 5, comma, some random expression. What should happen? What?
That's just fireplace.
F dot replace.
Oh, okay.
So that said fireplace.
It does
Like
look like
fire,
fireplace.
F dot replace. So let's say this looks like this here.
Well, it kinda
It'll
is fire.
it'll find the
I'm getting rid of a big chunk.
fifth node and replace it with a new expression,
So it should find number 5.
but there is no number 5 on that one that you just drew.
This one.
No, the one down there, the
So
in
I want
purple
to
that you
replace
just drew.
number 5. This is F here.
Oh, I thought
This
you
whole
were.
thing is F.
I thought the reason you drew that one down there was
No,
you
because
wanted
you
us to
replace
use
the 5
that.
with that.
Oh,
I want to
okay.
replace number 5 with this one.
Oh, okay. Yeah, then you find 5.
Uh-huh.
You got to remove whatever 5 is, and then you have to replace it with the new expression.
So whose job is it to do that replacement?
Once.
Number 1's.
But one doesn't know who 5 is.
One does,
Really?
he passes
One does
5
know
down.
who 5 is. Yeah.
One's got to know who 5 is. So you're going to have to think about this problem and go, if it's number 1's job to replace number 5, how does number 1 know that it is the parent of number 5? Let's say we were trying to replace number 15. Whose job is it to replace 15? 14's job. How would 14 know that it is the parent of 15?
15 is greater than it.
Well, so 16.
Because it passes
So
what number?
certainly if it's greater, it means the child is somewhere down below. What we want to know is, how does this node, number 14, know that it is